All right, good morning, everyone. Let's start the class today. I hope you are able to hear me clearly.
Yes, sir.
Yes, sir.
Okay,
Yes,
great.
completely.
Okay, good. Very good. Okay, so today we're going to start with the last chapter for your course this semester, and that's going to be file handling in C. Okay, so before we start files and file handling in C, let's discuss a little bit about what exactly files are and how exactly they are useful to us. All right. So we have done some standard input and output handling, right, in the previous chapters, right? You are able to read and write characters through your standard input and output, and you have been using printf and scanf. So printf is where you basically print the characters onto the monitor, the output device, and scanf you've been using to accept characters from your keyboard, which is an input device. So there is some level of standard input and output that you have handled. So in this chapter, what we're going to do is we're going to learn how to read and write the data, from a disk file. Okay, so that's what's different here. We have already been handling the reading and writing of data, but we have been using our standard input and output devices for it. We have been reading the data from the keyboard, and we have been writing the data onto a monitor. But in this chapter, we will learn how to read and write data from and into a disk file. Okay, so before we get into the details of how to handle files, it's important to know that this programming language that we are learning, C, it provides a very rich set of functions, library functions, to perform the input and output operations. We've already used two of them, right? We have used the scanf and printf, and they are very important functions. Okay. Now, a lot of these functions that are actually available in C, they can read or write any type of data to files. And what we are going to learn another set of some functions which will help us achieve this. Okay, so before we actually get involved with the IO operations on a file, let us first understand what exactly is a file, and it's important to understand what's a stream, right? We have already discussed streams when we were doing the input and output, the stdio.h. In the initial classes, I have given you the importance of stream and I've given you the fundamental concept of a stream, but I'll just touch upon it again because we are doing files which also involves streams. So what's a file? So in C, a file you can refer to as a disk file, right? A file which is available on your disk, that on your system, or you can also visualize a terminal as a file. Terminal could be a monitor, right? Or you could visualize a printer as a file, or anywhere where data can be written and read from. In other words, a file represents a concrete device with which you can exchange information, with which you want to exchange information. So any concrete device could be a disk file, it could be a monitor, it could be a printer with which you want to exchange information, can be visualized as a file in C. All right, so before you actually perform any kind of communication with the file, you have to do what? You have to open a file. So before we actually open the communication channel, before we actually do anything with a file, we have to open the file. And then what you need to do, we need to perform the operations. What kind of operations we can perform? We can either read from a file, or we can write into a file. And after we finish reading and writing, we know that we must close it, right? So if you're working with a physical file at home, the first important thing is you have to know where your file is. You have to connect to the file. So what you do, if you have a very important file which is in one of your wardrobes or in your cupboard, the first important step is, if you want to perform some operations on it, you need to first connect to that file. So how do we connect to the file? I need to establish a line of communication or a connection with that file. So I go to the wardrobe or a cupboard, and then I actually pick up that file. So when I pick up that file, basically I'm connecting to that file. After I pick up the file, I need to open the file, because without opening the file, I can't do anything with that file. So what we do, we physically open the file. And once we open the file, then I can access the internal contents. So what are the things I can do there? I can either remove something from there, or I can add something to that. So if I'm removing something from there, or if I'm reading some paper which is there inside the file, right, then it's a read operation. If I want to add another piece of paper into that file, so I write some document, and if I'm adding that document into a file, which means that I'm writing onto a file, right? And after I finish my read and write, I just don't leave the file open on the bed or on the table. What do? I need to close it back. And what do? I need to put it into the place where it was there before. So if you look at a file from a layman's perspective, we've been all using files at home. The same fundamental concepts are also applicable in your program. Okay, so a file, right, needs to be first accessed. That's the first important thing that we need to do when we're working with files. You need to access the file. Then what you need to do, you need to open the file. And after you open the file, you perform the operations on a file. Right? Operations could be a read operation, could be a write operation, could be, probably update operation or anything. And then once you're done with your operations, you need to close the file. Okay, fine. So those are a few of the operations which are, related to a file. Now, before we actually get into the file, right, we need to understand a little bit about a stream. I've already discussed this in my previous class, but I'm just going to give you another quick summary of this, because we're going to use it here itself. Now, the data flow, okay, the data flow you transfer from your program to a file or vice versa is called as a stream. That means a stream is nothing but it's a series or a sequence of bytes, or it's like a channel, or it's like a pipe, okay, through which your data is going to flow, right? Now, a stream is device independent, which means that I can take this pipe and I can connect it to a printer, I can connect it to a monitor, I can connect it to, a file, right? And then through that stream or through that pipe, I can, transfer the data. So streams are nothing. It's like basically a collection of, it's like a collection, it's like a series of data. It's a medium through which series of data flows. So for example, if I have my monitor here, right, and here is my central program. So this is my CPU where my program is running, C program is running. Okay, this is my CPU. This is my central system where my program is running. Now, if I have this monitor connected to my CPU. I can also have a printer connected to my CPU. I'm very bad at drawing, but assume that this is a printer, right? There's a printer which is connected to my CPU. And I also have a small file which is stored in my hard drive somewhere. Now, if I have some data which I want to print on the monitor, then I need to transfer this data somehow from the CPU to the monitor. And this is done through a channel called as a stream. Okay, this is done through a channel which is called as a stream. Similarly, if I want to transfer that data into a printer so that you can print it in the form of a document, then I need to transfer that through a stream. Okay, so stream is basically a communication channel. Stream is a channel. Similarly, if I want to, save that data into a file in my same system, then I need to transfer the data into that particular file. Now, when I transfer the data, that data transfer will happen through a stream. So this 1, 2, and 3 that you see here, they are examples of streams. Okay. Now, stream is device independent. All right, so all streams have the same behavior regardless of whatever device they are connected to or associated with. For example, in the first case here, we have a stream which is connected to a file. In the second case, we have a stream which is connected to a monitor. And in the third case, we have a stream which is connected to a printer, right? And you can also have a keyboard. right, through which a stream is connected. But in this case, the data is going to flow in this direction. But in all the other streams, the data is going to flow in the opposite direction. It's going to flow in away from your actual main system where the program is running. But in case of a keyboard, the data is going to transferred from a keyboard into your CPU or into your program. So the direction in which this data is going to flow in the stream is going to be different. Okay. However, all streams have the same behavior. All these perform the same behavior. They have the same behavior. What is the behavior? The behavior is flow of data. Okay. So to perform any kind of IO operations, you can read from or write to any type of file by simply associating a stream to that file. So what we need to do, if I need to take this data, suppose I have a data in my program which I need to transfer it. Suppose this is my data and I need to transfer it to my monitor. All I need to do is I need to look at the associated stream and put my data into that stream, and this will take it all the way to the monitor. Similarly, if I have a data which I want to print onto a monitor, all I need to do is find the associated stream, right? And what you need to do is just take this data and pass it on to the associated stream, and this stream will carry this data all the way into your printer and your document will get printed here. Similarly, if I have this data which I need to store it into a file, I need to save it into a file, and that's what we're going to learn in this chapter. What we need to do is just take this data and associate it with the stream, which is connected to this particular file, and this stream will take this data all the way to the file and you can store it in that file. Now, how can we associate? That's the whole question. How can we associate from a program? How can I associate it with a stream? And these are all done with your functions. What kind of functions? Functions which are already available in your C. Okay, they are built-in functions and they are going to help me associate. For example, we have already associated ourselves with the printf function. So whatever you write here, that's the data which is going to be taken and associated with the stream. So printf, you just write printf, and what happens is from the program, right, printf automatically associates itself with the stream which is connected to your standard input-output device, which is the monitor. And what the printf does, it connects to this associated stream and it takes the data which we write inside the printf function, and those data are actually put into the stream. So each of those data in the same sequence flows all the way through the stream into the monitor, and you see them getting printed on the screen. So we have already used printf, and the printf has already been associating itself with the stream. Similarly, we've been using scanf, right? We all have been using scanf. So what the scanf is doing is it is associating itself with this stream, and it is taking all the data which is coming from this particular keyboard. So all the data which is being generated from the keyboard is being taken by scanf, and it brings all the way to the program. Okay, so this is basically what a stream is. In a very simple language, a stream can be thought of as a pipe through which your data flows. Now, there are two kinds of stream. Okay, I'm just going to touch upon that. There are basically two formats of streams. The first format is called as a text stream. Okay, text stream is that stream through which your sequence of characters flow, that is text data. Okay, and each line of those characters in the text stream is normally terminated by the null. You have all learned about this new line character, and this is the new line character. Sorry, it's terminated by the new line character. Okay, that means a single line. When you go, this is the character which will terminate that particular stream. Now, text streams are normally used for textual data. Okay, it's used for textual data. And there is a second format of streams, which is called as binary stream. Now, this is again a series of bytes, but in this case, right, the data which flows is basically your binary data. Now, there are certain files, there are certain information which we have to store it in the binary format. There are certain information that we can store it in the textual format. So what we're going to discuss in this particular subject, in this particular chapter, is we're going to talk about the text stream. Okay, because we are worried about accessing textual data. But if you are working with videos, if you're working with what do you call audio files, or if you're working with even an image file, then you cannot represent an image in the form of a text. You cannot represent a video in the form of a text. Neither you can represent an audio in the form of a text. But all the video, audio, and all the other format, they can be represented in the binary format. So when we are working with applications which involve graphics, which involves videos, which involves image processing, then we will have to use the binary stream. But for your class, the scope is limited to your textual files and text stream. Okay, so did you understand what I told you about streams? A summary of streams?
Yes, sir.
Okay, that's great. Okay, so we can actually jump into the program and see how exactly files work. But before that, I'd just like to give you a small information, useful information, right, about what exactly is a buffer. Okay, you must have heard about this word called as buffer, right? Although it's not very important for you right now because we are going to jump into the program bit. But if somebody asks you what's a buffer, and as a computer science student, you must know what exactly is a buffer. Now, buffer is that area, a temporary area in the memory, okay, which is used to store the data before it is sent to the destination. That means buffer is a small temporary storage. Okay, this is your stream, and suppose this stream is connected to your monitor, right? This is a monitor. So this is a buffer. What is a buffer? So here is a program, right? This is your actual C program, and you are going to connect to the stream. So buffer is a memory area. This is a memory area that is temporarily used to store data before it is sent to the destination. Okay, what is the use of this? With the help of these buffers, the operating system can improve the efficiency by reducing the number of accesses to the I/O devices. Okay, which means that the operating system, see, it's a simple case. There are two things, how we can actually send the data to the monitor. See, in the first case, we are sending data one by one, right? So what is happening is the operating system like takes one data, transfers it, then takes the second data, transfers it, takes the third data and transfers it. Then maybe it has to wait because the fourth data has not yet come. So meanwhile, it has already gone and come back to the operating system, and it's held that connection with that device, the monitor. And then when the fourth data comes, then again it has to make an IO, kind of call. And then again the fifth data comes, and then again it waits and makes the IO call. But rather than doing this, what happens is we can put all the data in the buffer, right? And then we can start taking this data one by one into the monitor. Now, what is the advantage of this? What is the advantage of this? Now, if you use Netflix, or if you watch any live football match on your internet, on your Sony Live app, or any Hotstar app, you will realize that even what happens is buffering takes place. What happens in buffering? So what happens is the data, there is no straight channel between the actual server and your system. That means if there was a server and if there was a system here, and if there was a straight channel, then what would happen? If there was no buffer, what would happen was, as the data is released here, that data will reach here. So if then the second data comes here, it will reach here. So what would happen is you would have to wait for all the data to come one by one, and then you would actually see the football match or your cricket match or anything on the screen. So there could be an instance where there will be a lot of interruptions. That means depending on your network, there could be glitches wherein you'll see 2 frames, and then probably the third data would be arriving on the way, and then once it arrives, you'll see the 4th frame and the 5th frame, and there can be some kind of there could be some kind of glitches, there could be some kind of interruptions because the data is not released in at a go. because of some server issues, because of the load in the servers, or because of internet connection. So what they do is normally they have a buffer here. So when the first data goes, they keep collecting the data. So you'll find that as soon as you turn on your Netflix or your Sony Live app or your Hotstar app, what happens is, first some amount of buffering takes place. That means it first records, it takes around 10 seconds to buffer some data. So what it does is it starts storing some data here, okay, in that temporary memory location. Now what happens is, now when you, after 10 seconds, it starts showing you this data one by one. And while it is showing you the data one by one, it is also collecting the remaining data from the server and putting it into this buffer. So what happens is, even if there is some delay here, or if the network is a little slow, you have data which is going straight from the buffer into your screen. So there could be a continuous stream. So in the second instance, the viewing experience will be better because your data is coming from the buffer. So it's something like, you have a water storage tank in your house, right? All of us keep a water storage tank in a house. Although there is a connection supply, water supply, but we don't use that water supply directly into our bathrooms. Why? We can directly use that supply which is coming in bathrooms and everywhere. The problem may happen is, if there is an interruption in the supply, there will be an interruption in the water which comes from the tap. So in order to, overcome this problem, what we do is we use a water tank over a house. This water tank acts as a buffer. So the water supply first actually gets into this particular water tank, and from this water tank we use the water. So what happens is, even if there is some interruptions in the actual original supply, you can still have continuous supply of water from this tank, because you have already some amount of data which is stored into it. So your water tank that you use in your house is an example of a buffer. Did you understand what buffering is? Can you give me a quick yes or a no?
Yes, sir.
Yes. Okay. So when we talk about files also, we have a buffer. So using the help of buffers, the operating system can improve the efficiency by reducing the number of accesses to the IO devices, and things can become faster, right? So let's look at the basics of file handling. So let me get into a new page. Okay, fine. So the first important thing, when we look at file handling, we need to use some functions which are going to, these are going to be the functions which are going to help us in perform the file operations. So I'm just first going to list down some of the functions, okay? So some of the common functions that we're going to use is this. So we're going to have the file open. So as it's mentioned here, this is going to help us open the file, right? And then we have the function called f gets, we have the function called f puts, right? And then we have the function called f close. So we will be working with these functions. Okay, so these are some of the functions with which we will be writing programs to actually see how we can enter the data or read the data or write the data into a file from a file. But before that, in order to work with a file, we need to first use a file pointer. That's important. Okay, first we need to use something called as a file pointer. Now, what is the use of a file pointer? So the file pointer is basically like a handle to the file. So when you have a file, you need to access that file to perform some kind of operation. So for example, if I want to open a file, so you need to know which file it is, right? So you need to actually have the address of that file. Or if you want to read the file, so in order to read the file, you must know which file I need to read. So I need to know the address of the file or the location of the file. So the location of the file needs to be, stored somewhere. I need to keep the location of that file somewhere, and that I will be keeping in a pointer variable. And what kind of pointer variable? It is not going to be an integer or a kind of a floating point pointer, but the pointer which I will be declaring it is going to be with a data type file. Okay, so now this is a special pointer called as a file pointer, which is used to declare a pointer which is going to store the address of a file, and using the address of the file we can now do the operations on the file. Okay, so the first important thing is this one. You need to have a file pointer. This is called as a file pointer. Now remember that all these functions do not need any special library header files. All these are available in your stdio.h. Okay, so when you include hash include stdio.h, these functions along with printf and scanf are also available there. Okay, so first step before we do any operations on a file, what is the first step before we do any operations on a file? So the first step is to open a file. So you see that there is a function called as fopen, right? Now the fopen is a function which takes in two parameters. Okay, two parameters. What are the two parameters? The first parameter will be the name of the file that you want to open. So say my name is name.txt. So this is the file. I'm working with text files. So this is the file which I want to open. So I need to give this as the first parameter. And the second parameter defines, say I'm going to write W here. The second parameter will tell me the mode in which I want to open. What is this mode? Now this mode is basically, there are different kinds of mode. So you can open the file in the write mode, in the read mode, in the append mode. So the kind of operations that you need to perform, you have to use the appropriate mode. So let me just give you some of the very common used modes. So W, what does W mean? W means that we are opening the file in the write mode. So what is going to happen here? So when I write fopen name.txt w, right, this function is going to search for this file. And if the file exists, right, then whatever we are going to write, it will overwrite with the content which I will actually specify. Okay, if the file doesn't exist, for example, this name.txt doesn't exist at all and I'm trying to open it, then what it is going to do? It is going to create a new file. And what will be the name of the new file? Name.txt. Okay, and whatever I want to write onto a file, I can write onto a file. So remember this W is a mode which is used for writing into a file, but if this file already exists from before, it will replace all the contents of the previous contents of the file with the contents that we try to write onto it. Okay, so if the file does not exist, it will create that file automatically and it will write the contents which we specify into that file. So this is the write mode. All right, there is another mode called as R. So in case of R, so if I open the file with the write mode, that is R mode, in the read mode, that is R mode, right, it will search for a file. If the file is found, it will successfully open that file into the memory, right? And then it will point to the first character in the file. So then once it points to the first character in the file, I can start reading the characters from the file. And if the file cannot be opened, if there is some issue, then it will return null. Now, a very important point, fopen is a function which is a built-in function of the C language, right? It is used to open the file in a specific mode. Okay, in a specific mode, read mode, write mode, append mode, there are different modes. Okay, we will just discuss the read and write modes for now. It will open the file in a specific mode, and If there is any problem in opening, if the file is not found, there is some issue and this function does not work, some connection issues happen, the stream has a problem, it doesn't connect to the stream, there are so many other issues that can happen. So if it doesn't open the file or it doesn't perform the operations that it is supposed to due to some issue, it will return a null. It will return a null. If it finds the file and opens it, or creates the files and opens it, then it will not return null. But what it will return? It will return a pointer or an address to that file. So if it is returning a pointer or an address to a file, then I need to have a variable which is going to store either the null value or it is going to store the address of that file, because the fopen function returns the address of that file which it has opened or created, right? So I need to have a pointer variable which is going to take the address or capture the address of that particular file. Now, what we are looking here is not an integer, not a floating point number, not a structure, but it is a file, right? So this is going to be the address of a file. So my pointer variable also should be of what type? The file type. And here is what I have declared. So here is a pointer variable which I have declared it of a file type, and this pointer variable is going to now store the address of this file name.txt if it has successfully been opened. If this could not be opened, then ptr will be storing what value? The null value. Is that clear? Did you all understand? Can you, yeah? Can you quickly give me like yes, no, if you've understood? Okay, fine. So what we have just seen right now is how to use this file pointer, right, to hold the address of the file. Now, once we have the file, we have the name.txt. Now I know that name.txt, the address of name.txt is available in ptr. Now, once it is available in ptr, now I can start doing operations on it. So let's start, doing some kind of operations. Let's do the write operation first. Okay, let's do the write operation first. So let me just start writing a program so you can understand with a program. So I'm going to write a small program to perform a write operation. That means I'm going to open the file, write something onto a file, and then I'm going to close the file. A very simple operation. Okay, so let me write this program and then I'll explain it to you. So first thing, we need to include some header files. So which is the header file I'm going to include. Now, as I told you that all the functions that I talked to you about, fopen, the gets and puts and fgets and fputs, all of these are available in the standard input output header file. So you don't have to include any additional header files. All right. Now, let me keep one more space, one more header files in order to do some operations. Let me say string.h. I will use the length of the string, so I will add this header file. Now let's start with a main method. So here is my main method. Okay, all easy. Okay, so first thing, let's declare some data which we want to write onto the file. Okay, that's important. So let's store some data into an array. Let's open a character array. So let's initialize a character array. So let's say I have a character array, and let me write data, and let's give it the size, say 30, right? And let's initialize this character array, and let's say hello, how are you? So this is basically my character array, and this is the content which I want to write onto a file. Okay, so I've got my content ready. I can take this content from the user and all these things I can do. There's no problems with that, but just to make things simple here so that we focus on the file rather than focusing on how to accept data from the user. So that's it. Okay, so here is my data. Hello, how are you? And this is what I want to write onto a file and store it. Fine. So first thing, we need to declare a file pointer. So how do I declare a file pointer? So here is, please remember that all these FILE has to be written in caps lock. Okay. So file pointer, and then let's say PTR. Okay, that's my very common name for a pointer. So I have a file pointer. Now I need to open a file, right? So what I want to do, I need to take this PTR because this is the pointer variable where I'll be storing the address of the file which is opened, and I will be using the fopen function. Sorry, there's some mistake here. So it's fopen, right? So this is the name of the function. This accepts two arguments. One is going to be the name of the file which is going to open. So let's say my file .txt. This is the file which I'm going to open, or if the file doesn't exist, it's going to create this file. So which mode I need to use in order to write things onto a file? I need to use the mode called as write mode. Okay, what this is going to do is it's going to check and find whether this file exists from before. If it exists from before, it's going to, overwrite this content. If it doesn't exist, it's going to create this file and then write this content into a file. But it's not going to happen automatically. We are going to check, first whether there is an issue or not. So first important thing, we need to check whether this fopen worked fine or not. That's my first thing. If fopen doesn't work fine, then we can't do anything, right? We cannot, that means the file is not created or file is not open. So in order to check that fopen works fine or not, we will check what is the value of PTR. Okay, if the value of PTR is null, then we know that my fopen did not work fine because of some issues, maybe a stream issue, maybe something went wrong. So the first important thing is always check whether your fopen worked or not. So in order to check that, I will use a simple if condition to check whether the value of my PTR is null or not. So if my value of my PTR is null, right? If it is null, then I know that something went wrong, right? So what I can do, I can simply write a message saying that file opening failed. There was some issue, we don't know. So your user will at least get a message saying that, okay, there's something happened. The file did not open. Now, if it opened, that means we are looking at the else part. Okay, that means if condition is, if PTR is equal to null, if it is satisfied, then it's going to print this and we're going to close it. But if the PTR is not null, that means, oh, great, fopen worked fine. And now since it's not null, that means it is storing the address of that particular memory location where that file txt is created. So basically, my stream is connected. My stream is working fine. Right. Now, inside this else, what I'm going to do is I'm going to start writing the data into the file. So how will I write the data into a file? Now I need to use another function. Now, which function I'm going to use? I am going to use a function called fputs. So let me write the name of that function. Okay. Now, what is the format of fputs? What is the format of fputs? Okay. Now, fput, you can have two arguments. Argument 1, argument 2. The first argument is going to be the data which you want to put into a file. So this is going to be data. So I say, hello, how are you? This data has to go as my first argument. And the second argument will be the address, the pointer variable, which is pointing to the file where you want to write it. So in my case, which is the pointer variable? My pointer variable, which is pointing to my file.txt is PTR. So in this fputs function, my PTR will go as my second argument because that is the file to which I want to actually put this data. And the data which I want to put into that file is going to be my first argument. Okay, so let's just write that line of code. So the first thing I'm going to do is I'm going to use this fputs, okay, and this is the data which is going to be written. So in this case, which is the data, this DATA, that array is basically holding on to my data. So I give that array name because that's where my data, hello, how are you, is written there. And the second thing I need to specify is the file pointer, which my what is my file pointer? PTR. Okay. Now this is basically what's going to happen here. Now fputs is going to take the data and it is going to write it onto a file which is pointed by PTR. So my file.txt, this hello, how are you, is going to be written into a file. Now, when we write onto a file, always we need to ensure that we need to add one more character, which is the new line character, into as the last element of that file. Why this is done? Because when we are reading the file, right, there is another function called fgets. This is useful for in reading the file. Now this fget will read the file, and when it encounters the last character, it will stop reading the file. So it's important to give this new line character at the end of the data, so that while reading the file, it is useful for the fget function. So once this puts in this data into my file, I am going to add another data which is /n. So what I'm going to do is I'm going to add this /n to the end of this. So hello, how are you, /n will be put into a file. Okay, now this is only for, it is not an additional data which is going to be written into a file, but this will be like a data which will help us while reading. Okay, so what we need to do is PTR. So what we have in the file, hello, how are you? And there is a /n. That's a new line. You will not see the /n inside the file. So when you open the file, the /n will not be actually visible to you. Okay, this is a new line character. Right, so that's it. So this program will write hello, how are you into the file. However, as I told you, when we are actually using a file, it's very important for us to close that file. What happens with close? So fopen is a function which establishes the stream connection. Okay, the fopen associates the stream through which the data needs to be transferred. Now this stream, this is already connected to that pipe. That means fopen connects to this file a pipe, okay, which is a stream. And through this, we are taking the data and we are entering the data into the file. However, once we enter the data, we also need to remove this file. We need to remove this connection, or we need to remove this stream. Otherwise, what happens is one resource is unnecessarily occupied. So in order to close this stream connection, or in order to remove this pipe, we need to close the file. And that's the importance of close. So it's very simple. You just use fclose, right? And you use the PTR, the pointer variable, which is pointing to that file. So as soon as you write this line of code, the connection, that means the channel which was opened to perform read or write operations by fopen, is removed, and this resource is freed. And also the buffer is removed. Okay, all the buffer and all the stream, channel, network, everything, the line communication, everything is removed. So now this file is free. It doesn't have any stream connected to it. And that's it. So that's where our program ends. And then you can close this and return 0, and that's it. So that's the end of your simple program. Now, if you'll notice this program, it's very simple. If you execute it in your system, you will have a file created in the same directory where you have stored this program, right? And the file name that will be created will be myfile.txt. So we have used 3 separate functions here. Fopen, only 3 functions, sorry. Fopen, then we have used fputs, and we have used fclose. So these are the 3 additional functions that we have used today. Fopen, what it does, and what is the mode in which we are opening the file? We are opening the file in the write mode. So if this file exists, the contents will be overwritten. So if the file does not exist, this file will be created. And what is going to be entered into this file? hello, how are you? How? Because we are using fputs function. What fputs does, it takes the data which is stored in this array, and it will actually transfer or write the data into a file which is pointed by this ptr. Which file is ptr pointing to? Ptr is pointing to myfile.txt, right? And after we write the contents, we close this. So when you run this program, you go to the directory and you'll find that an additional file has been created, myfile.txt. Open the file. Once you double click and open that file, you will find that hello, how are you is written inside that file. So this is a simple program by which you can write into a file. Okay, so did you understand this? I've tried to make this file handling as simple as possible. So you can actually write this program and see, and it will run. Definitely, it will work. Any queries? Any questions that you have? Did you understand this?
Yes, sir.
Yes,
All
sir.
of you, did you understand the simple example of how you can open a file, write some content into a file, and close the file? And also important is to understand the concepts of streams. Yes?
Yes, I got it.
Sir, uh, sir, when we use the write, then it takes the we can use a file from anywhere.
Anywhere in the sense?
Like you said, sir, when when we save this file, it will be saved in the same directory where we save
Yes, yes,
the.
yes. So this will basically, only look for the directory where you are storing this particular program, because it's a current directory. That's the directory you're working in. So if you compile this program, all your object files and everything will be saved in the same directory. So your file is also going to be created in the same directory.
If another file with the same name is there in some other directory, then
No, it will not search for it. It will not search
yes,
for
sir.
it.
That
Okay,
was
it will search only in the current directory.
yes,
Otherwise,
sir.
there'll be a problem, right? You can have some file somewhere and then it will replace that. No, it will not do
Yes,
that.
sir.
It will not
Yes,
do
sir.
that. It will just look for a file in the same directory. Okay,
Yes, sir.
fine. So if you're fine and if you've understood this first class, tomorrow we're going to start looking at how we can read from a file, right? And once you know how to read and write from a file and to a file, write to a file and read from a file, then you can start using this file operations with lots of your other programs. So basically, if you have an output of a program, rather than printing the output onto the monitor, you can take that output and store it into a file, and then you can open that file and see whether that output is correct or not, right? You can write this file program and integrate it with your other programs, and then you can actually see how useful it is. So the basic file handling is what we need to understand, and after that the applications of this is varied. You can use this to store your data, you can use it to take information from the user, you can create a simple address book for yourself. So you can create a simple application, take the data of 10 people, make a structure, take that structure data, and you can pass it into a file and store it into a file. So all that stuff you can do once you learn how to read and write to and from a file. So with that class, with that note, we can close the class today.